Okay, so we have so far started our layered architecture discussion in data networks. So we'll continue on that same discussion, that how a particular layered architecture that we have just discussed, that TCP/IP layered architecture. So how that actually facilitate the whole communication, and how the task has been modularized and subdivided into different layers, and what are the functionality of each layer. Very briefly we will tell, and then we probably will continue on discussing about a specific layer one by one. Okay. So, if you see over the few course of our lecture, so what will be mostly covering this TCP/IP layer, that is the first thing that will be covering. So, which will be the primal focus of our today's discussion. Then we will go to the layer 2. Layer 1 is the physical layer. Most probably in this particular course we do not want to discuss that, it is a point to point link and physical layer whatever we do. But layer 2 onwards, that is the most important part. So, there we will try to understand how this layer 2 is being facilitated. Mostly it is part of the access or where the network gets interfaced with the user, that is where it is being used. So, we will give a brief history of this basic broadband access which has been traditionally being done, which is dial-up ADSL. So, that was just the bridging between circuit switch network towards packet switch network, and then we will come to more advanced means functionality of layer 2. One of them is media access control, we will talk about that, and then start talking about some typical protocol that has been historically developed like Aloha, slotted Aloha. Then we will go to CSMA/CA, CSMA/CD and all kinds of things. So, that should be our brief outline of discussion that will be happening over next 2-3 lectures. Okay, let's try to see what we have been doing. So, basically what we have told, so it should be something like this. So, there is a station through which you are probably accessing the these things. So, from there it tries to access a common media, let us say, or the access network part. Okay. So, and then it goes to a particular, we will try to appreciate this part. So, a switch, okay, which is the local switch probably, where it goes from here to here. Then from switch probably it might go to multiple other switches, higher aggregation switches, almost similar like our circuit switch network. So, there will be from switch to another switch it might connect and so on. Finally, it will go to some router, okay. So, which might be the access gateway of let us say I am in a campus and I am trying to access. So, first I go to the next switch and then from that switch I go further multiple switches and then aggregation switches, and then finally go to the access router probably, or aggregation router or gateway. So, this is the edge router I should say, and from there it hops through multiple routers of different capability, and then finally it goes to the other end access router or edge router similar to that, then from there to a switch and then to the user. Okay. So, this the connectivity generally happens. Okay. It might also happen that this is not another user, this might be a server. So, that is also possible. So, it is instead of that it goes to a server rack. Okay. But that server also will be locally connected to some local switch and then connected to a access router, and then via multiple routers it goes to the other end. Okay. So, this is the full picture of the connectivity. Now, let us see how the actual connectivity goes on. So, basically over here whatever user is trying to do, he will be having a application layer things where he is actually putting the actual data. Okay. So, let us say it might be your HTTP this www web page browser, where you are actually inserting something, or you are clicking somewhere, you are typing something, okay, or you are typing just the address. So, something like that, whatever you are doing. So, that is actually the application layer, actual data you are providing. So, you get raw data. So, it is a data chunk, so which you actually give it to the application layer. So, this will be having an application layer sitting over here in the machine, and this data will be submitted to the application layer. What the application layer will do? He will first packetize this data, because we have already seen it's a packet switch network. So, he has to packetize the data. He might have some restriction on size of the data. So, he will accordingly he will decide to packetize the data. So, he will subdivide it into multiple chunks. So, data will be subdivided into multiple chunks, and then what he will do, he will actually add header, which is called the application header, to this data, and for each data he will be putting his own application header, and they might be differing with some aspect. We will talk about this aspect, what are the aspect of this header. So, header will have some field, specific field according to the protocol, which has to be properly this application layer has the task of putting those headers or making that header. So, basically he has few tasks. One of the tasks is take the application data chunk, you subdivide it into multiple segments, packet segments. Okay. So, that packet segments, which we call the data segment, that is being appended with a header which is prepared by the application layer. Okay. What are the functionality of those header, what each bit specifies, how you actually put those things according to your wishful operation. So, that we will discuss later, but this is what application layer does. After doing this, what it does? It actually releases that data towards the next layer. Let us call that in TCP IP, it is actually at the transport layer. It is the transport layer. Okay. So, the transport layer, what it does for him, this is the whole packet. So, this is how the layers actually function with each other. So, the upper layer just gives the data plus header to the next layer takes that as if his own data, the whole thing, the data plus application layer, that is his data. Okay. So, he takes that whole thing and then he starts appending his own transport header. Okay. So, a specific transport layer for TCP IP is TCP or UDP. Okay. So, they will put their own header. We will also when we will be discussing this particular layer, we will be discussing what exactly it does. So, basically he will add his header. In that header, all the functionality he will be putting according to his jobs that he has to do. So, basically all the jobs of networking has been now segregated into layers, and they have been segregated in such a fashion that one after another it comes. So, there is a layered structure and the application layer does its things, and then it handles or gives the handling of the data to the transport layer. Transport layer oblivious of what application layer has done. So, entire thing he takes as data and then he appends his own header according to his functionality. Similar things will happen next layer also. So, from transport layer it goes to the network layer, which is IP for our discussion. So, IP layer will take this entire thing as packet and he will add his header, which is the IP header. Okay. And so on, it goes on like this. So, from network layer, the next layer will be, if we can demonstrate, the next layer will be, so from over here if it goes, so the next layer will be the data link layer. The same thing will be happening. Again, he will take the entire thing and he will put his DLL header. Okay. And so on. Last layer, which is the physical layer. So, he will also take this whole thing and he will add his physical layer header to it. Okay. So, everybody, all these layers starting from application to transport to network to DLL to physical layer, they actually one after another takes the data given by the above layer and then encode it with, not encode, it actually appends it with its own header according to his own functionality. So, this is how it operates. So, basically the data will be given to the application layer. Whatever you do in your machine, always all the layers are sitting. So, whenever you are accessing, suppose let us say HTTP browser or whatever network functionality you want to do, suppose you want to send email. So, basically all you do, whatever you type, that is given to the, you have an interface which is the application layer interface. So, if it is your Gmail account, so it is the mail interface. Okay. So, application is called the email service. Whereas, if you go to some let us say Google search engine, so it is that search engine's interface. So, you have this application interface where you submit your data. Now, what they do, this application layer, first layer will be application layer with some functionality. It will try to append, it will first segregate the data, make packet and then append his header according to his own understanding of what he needs to do. All the application layer, whatever he has to do on that data to transfer the data from one end to another end, he will be doing those things, those functionality, and those functionalities are encoded by the means of header and associated protocol. We will discuss that later on. Similarly, after application layer, that goes to the transport layer. Transport layer does the same thing and they keep on doing it. So, this is the communication which will be happening in any station. Okay. So, in any station where the initialization of the communication is happening, all 5 layers, or if it is OSI layer, all 7 layers should be there, including session presentation in between. Okay. So, all layers should be there, it should pass through all layers, every layer will be adding its own header. It is like when you post letter, what the post office does, actually post office gives you a envelope, you put your data inside the envelope, think about that, or you put your letter inside the envelope. So, think about that letter to be the data and you actually put it inside the envelope, this envelope is the header. In the header you specify something, so the addresses and all those things, right, address, pin code. In address also there are separate segregated things, the state, the district, then the city, then probably the road, the number of the house, so all those things you specify, those are actually the things, extra things that you put to encode it such that this letter is properly delivered to the destination. Okay. So, as you can see from the letter analogy, that addressing is one of the important part. So, you will see later on when we will be discussing about specific headers of each of the layers and their associated protocol, addressing is one of the most important scheme which is there, and it comes from that letter analogy actually, if you see. So, basically you put that and then what happens, seeing those address later on, whatever other post office will be taking that, they will not call you, the users is no longer important, it is all given in the letter, means in the address field of the header or the letter, that where it has to be delivered. They understand that and they will be exactly taking it. So, first they will see which country it has to go. So, it will go to the first half of that country. Suppose it has to be, it is posted from some other country, let us say US to India. So, first it comes to India, the first hub, either Bombay or Delhi. Okay. So, from there it tries to see which particular state it has to go. Suppose it is written as West Bengal. So, it comes to West Bengal next. So, it comes to Kolkata. Then it tries to see which city it is specified. So, if it is specified that it is in Kharagpur, so it first tries to see which district it has to go. So, it is specified that it is West Midnapur. Okay. So, you go to that district and then there it will be specified the city, then you go to that city, then the post office, then the street address, then the house number. So, accordingly seeing each one of them, you decode one by one and then the data gets delivered. Okay. Same thing happens over here. So, there will be addressing, we will also talk about those addressing scheme in terms of IP layer or even in DLL layer. We will start means seeing how those address actually is, addresses are so important and how seeing those address like the letter analogy or the letter delivery analogy, this data are being delivered. Always remember, we have talked about this also. All these things has been taken from our daily life analogy. So, the way we do things, the way we transmit things, we communicate messages. We used to communicate messages through post office and through all other schemes. So, that has been just copied or borrowed, those ideas are borrowed over here. So, headers are serving those purpose only. Okay. So let us now try to see how these things actually, this entire protocol actually is being functional in the network. So this is only one end of the network I have seen, that is one user is trying to transmit data. So what will happen, his data chunk will be keep on appended by the corresponding layers header, and they have a sequence also. The first application layer headers will be added, next transport, next network, next DLL and next physical layer, and the processing also will be done in this sequence only from top to bottom. So first application layer will handle the data, then it will actually give the handle to the next layer, which is your transport layer, then transport layer will handle the data and so on. They will just do that. Then when it comes to the physical layer, this entire chunk of data including the physical layer header, that will be launched to the media. Okay. So whatever the media might be, the media might be a Ethernet connectivity, a LAN connectivity, it might be a means wireless connectivity like your 5G mobile connectivity, or it might be Wi-Fi connectivity that you are having, or it might be a satellite connectivity. Whatever the media is, that user's physical layer is responsible to launch the data in the physical media, and accordingly he will do his physical layer encoding. So if he has to do modulation, if he has to do any other channel coding, source coding, so all those things he will do, so that he can combat the channel. So his target is just to facilitate the data transmission from this point to the next point. Okay. So let us say, as we have demonstrated, that this will be, this data goes to the next switch. So what will happen to the next switch? Let us try to see. So this data now gets transferred to the next switch. What the next switch will see? Next switch will see this data appended with a physical layer header. So now it will be delivered to his physical layer, the switch physical layer, which is interfaced with this particular physical layer. So therefore he absolutely understands this particular physical layer. So if it is a wireless interface Wi-Fi, so you are going to the next let us say your Wi-Fi access point. The access point, that interface, he knows exactly what to do with this physical layer. So he has full understanding of that. If it is Ethernet switch, so the switch port where you are transferring this data, so that switch port knows exactly with this physical layer what he has to do, what kind of data transmission is being done, what kind of modulation has been done, what kind of channel coding, source coding, and all those things are well aware of. Okay, in that switch interface. So that interface physical layer, corresponding physical layer will receive this data. What he will do? For him, this part, which is the data part of him, he does not care about this part. He will just be caring about the header. So he reads that header and accordingly he does things. Okay. So whatever things he has to do, he only takes information from that header. So how he does that? Let me give you one example of this physical layer task and how the header helps it. So basically physical layer, he will be keeps on getting packets. Every packet he will be adding this physical layer data. So basically when he is transmitting, he will be transmitting a series of such packets. Every packet is followed by a physical layer header, okay, and then the next packet followed by a physical layer header and so on. So for the channel, it is just like a bit stream. He cannot be it header or data, it is all data, right? It's all means it's all binary sequences. So basically on the other end, when the physical layer receives it, he sees continuous streams of bits coming. So it's a bit stream which is coming to him. Now how does he know that where one packet ends and where the next packet actually starts and where the header location is? This particular thing is being facilitated by the header. So basically what will happen, in the header there is something called this identification of frame identification, or it called the packet delimiter. So that's actually what says that it is the starting point of the packet. It's a bit stream, but what will happen, there will be a unique bit stream that will be encoded, let us say 8-bit or something, some particular unique stream will be encoded and none other bit streams will be having that same encoding. And from there he will be able to identify. So let us say if the bit streams are being transmitted, so I have something like, let us say 10, 10, 10, 10, that is the header initial bits which are transmitted. After that, whatever I will be encoding, I will do my channel coding and source coding in such a fashion that never this particular part is being repeated. So, if that is happening, then after that all these things, all these bits will be there, but never this signature will be repeated. If this happens, then I can identify this signature and can tell, okay, this is probably the boundary of a packet. And then again in the next packet, I will be having same signature over here. So, that signature will identify next packet's first bit. Okay. So, he will identify that this is some redundant bit and this is the first bit of the next packet. So, from here up to some number of bits there will be there which will be identified as the header. What is the length of that? That also will be encoded over here and that bit position also will be given. So, that is the functionality of the header, as you can see. By reading the header, you will be able to, or you will be facilitated to do all these things. So, when the bit stream from channel is coming, you do not know exactly where the packet is located, but this particular things actually facilitate you, and that is the redundant part which should be already part of physical layer header, because it is helping you to identify where the data ends and where the next data starts. So, he will help you to identify these things. So, these are the functionality, as you can see, that is just one functionality I have talked about. Okay. Of course, he has to know some more things. In physical layer, you need to know the channel, you need to know what kind of modulation schemes he has applied, you need to also know how to cancel out the effect of channel. So, all those things are facilitated by the physical layer header. And how that is being done, that is specified in the header and associated protocol. When we will be discussing, of course, the physical layer we will not be discussing in details, but all other layers we will discuss and it is similar to that. Okay. So, we will see that. But this is just to give one example to you how this is being, means how the functionalities are being performed with the help of the header. So, okay, what physical layer will do, once he identifies where the header lies, he will take out that header. According to that header specification, he will do the processing on the data. So, if he has to demodulate the data, whatever channel encoding has been employed, if he has to reverse that. So, all those things he will do, and then the raw data he will supply to the next layer. So, this data after some modification will be given to the DLL layer, corresponding DLL layer. Now, what happens? Now, DLL layer, after getting the data, he knows that what is his header. So, he will be concerned about his header, he will take that header. Okay. So, he will take that header and along with that header only his entire processing will be done. We will discuss about that when we will be discussing DLL layer, but he will take that header, he will now understand what this guy has put. So, basically virtually he is communicating to his own other side DLL layer. Accordingly, they can fix things. Okay. So, whatever he will be putting in header over here, he will be able to read over here. That is the communication. Intermediate communication or the control channel is being set up through this PR communication. So, basically you will see always layer to layer PR communication happens through the header, and all layers actually gives its subsequent layer either in this direction when the data is being received and being further processed. So, it will be going from bottom up. So, from physical layer it will be given to the DLL layer, he will take his header and rest of the things he will deliver to the next layer if it is required. Okay. If not required, that is where they will end. Okay. So, like this it will be happening. If the data is being to be transferred, then it goes in reverse direction. So, basically from the top layer one by one everybody will be appending header and delivering the appended data to the next layer. The next layer will be doing that, and this is how layer to layer, means peer to peer, they communicate among each other. Like over here, as you can see, DLL layer communicate to the next DLL layer. Okay. Suppose this is a switch, okay, as described over here. So, this is a switch. So, in the switch generally it goes up to data link layer only, it does not go any further. So, basically what he will do, he will keep this data intact and he will do nothing on the other interface. So, switch has two interfaces, as you can see, switch is connected to the user and switch is also on the other side connected to the router. Okay. So, in that other interface he has another DLL layer, it might be a different technology. So, over here it might be wireless, over here it might be a Ethernet LAN. Okay. So, on the other side it might be a Ethernet LAN. So, if that is the case, then it needs to have a different, because Ethernet will have a different DLL protocol, different physical layer, whereas wireless LAN will have a different physical layer and different protocol. So, of course, what he has to do, he has to transfer to the other interface DLL layer. What he will do, he will just give that same data will be given, only now he will put his own DLL header. So, if it is Ethernet protocol, then he will be putting Ethernet LAN header. Okay. So, he will put that, and then similarly like over here whatever has happened. So, he will transfer it to the other side's physical layer or other interfaces physical layer. He will then add his physical layer on top of this and transfer it to the Ethernet LAN. This will then go to the next router, let us say. In router it goes up to, again same thing will be happening. So, if it goes to the next router, so if you just construct that, so in the router what will happen, this data comes to the router physical layer. So, router physical layer will strip off the physical header, it will give to his own DLL layer, then DLL layer will give to the next layer which is the IP layer, where IP does the routing functionality. Okay. So, it will take the header, do the routing functionality, that means which port to forward to reach the destination. He will do that functionality, he will give to the other interface wherever it is transferring. So, from one router, see the router is connected to Ethernet switch, on the other side it is connected to another router. So, on that side he will put another DLL, because this might have a different LAN functionality or different kind of access functionality or different DLL layer functionality. So, that might be a token ring, let us say, or it might be a some other kind of point-to-point protocol. So, if that is the case, then accordingly that DLL functionality will be added. So, basically this IP layer, so whatever packet he gets over here, stripping off the IP header, the other IP will take that same packet, the packet will remain the same, but the header might be changed if it is required, not always it will be changed. He might also put the same IP header over here. If it has to be changed, he will modify that, he will add that, then he will supply this to his DLL layer. Now, his DLL layer will put his own DLL header, and then his physical layer will put his physical layer header, and that will be further transferred. So on it goes on. Up to whichever layer, intermediate nodes, up to whichever layer functionalities are required, up to that they will go. Okay. This IP layer then actually, as you can see through this header, he talks to the IP layer of this source. The next IP layer will talk to the next IP switch or router, whatever will be there, his IP layer. So, peer to peer there is a communication, and then there is a communication vertically up to down and down to up, depending on if you are transmitting the data or if you are receiving the data. So, this functionality in the overall network goes on, and all the functionalities are accordingly being processed. You will see each of the layer what they do. So, we will talk about that in the next class. Okay. Thank you.